Let's do our Chinese today.
Well, we're gonna try. Just not sure why nothing's coming up. Here we go. All right, factors, simplest form. So the way this book teaches us to factor equation or fractions and put them in simplest form is to write the prime factorization of each number and cancel out anything that is similar. All right, that might seem a little more difficult than what we're used to doing. However, it is a good method to learn. So, to perform many operations, it's necessary to be able to factor a number. Remember that factoring a number just means writing down the things that multiply up to that number. So 7 and 9, or 7 times 9 is 63, then 7 times 9 is the factorization of 63. So taking that to the next step, we talk about prime factorization. So prime numbers. A prime number is a natural number greater than 1 whose factors are only 1 and itself. You guys know that, right? A prime number is a number that only has the factors of 1 and itself. It cannot be divided by any other number. So when we talk about prime factorization of a number, we're talking about a composite number that is written as a product of its prime numbers. We might get to that on another slide, so you can write it down. So let's talk about examples of prime and composite numbers. Is 16 a prime number or a composite number? Composite. How do you know that? Because 8 times 2, because it is an even number. Any even number is a composite number. What about 31? It is prime. Nothing else multiplies up to 31. What about 49? Not. It is composite. What are the other factors of 49 besides 1 and 49? 7 times 7. So when we talk about prime factorization, the prime factorization of a number is the factorization in which all the factors are prime numbers. So the factorization of a number where all the factors are prime numbers. So, over on steps to solve, you'll see the prime factorization of 30. 30 is the same as 6 times 5. Remember, we're working on prime factorization, so we want all of our numbers to be prime. 6 is a composite number. 6 can be broke down into 3 times 2. So when we break that down into prime factorization, we have 3 times 2 times 5. That is also on the back side of your paper. Boop. It's also on the back side of your paper for you to solve if you want to write that down. It's on the front side and the back side. Looks good to you. answer on the back side?
No. I already did.
Sweet. So our next number we are going to factor is 36. Write the prime factorization of 36.
Dang, I actually can get this, man.
Sweet.
That's easy. Easy.
Good. That's what I like to hear.
Literally, we're just trying to find the number, right? Time thing.
Like that?
Oh, I
Yeah.
got 6 times 6, but whatever.
Hey, guess what? It works out to the same thing. No matter what you pick, it should work out to the same because then it breaks down to 3 times 3 and 2 times 2. When we write that as prime factorization, and this is how it will have to be on your homework, you need to write it like this down here where it shows 3 squared times 2 squared because we have 3 times 3, that's the same as 3 squared, and 2 times 2 is the same as 4 squared. So on your homework, when you log in online today, it needs to be in this form. If you have a factor more than once, you have to have that exponent with it, okay?
How do you, like, how does that, like, work exactly? Like, how do we break it down like that? I'm confused a little bit.
How do you break it down like what? Like so that it's 3
Like,
times 3 and 2
figure it out
times
yourself.
2? No, I'm just confused as to what you're asking.
You can just put, oh, I see how we do it. Never mind. I got it.
Okay? So, the divisibility test. These are going to help you determine what is divisible by what number. Alright, I handed you a whole separate sheet of paper that goes through the numbers to tell you how to determine whether something is divisible by a number. So by looking at a number, if the last digit is even, it's divisible by 2. If the sum of the digits is divisible by 3, the number is divisible by 3. What does sum mean?
Add. So,
Add. The answer to an addition problem. So pretend like you didn't know if 15 was divisible by 3. What is 1 plus 5? 6. Is 6 divisible by 3? So 15 is divisible by 3. What about 333?
Yep.
Yeah, what's 3 plus 3 plus 3? 9. Is 9 divisible by 3? So 333 is divisible by 3. For number 4, the last 2 digits of a number that is, the last 2 digits form a number that's divisible by 4. So if the last 2 digits are a 1 and a 6, like 316, 16 is divisible by 4, so 316 is divisible by 4. 424, 24 is divisible by 4, so 424 is divisible by 4. 5s obviously end in a 5 and a 0. 6s, if a number is divisible by both 2 and 3, it is also divisible by 6. 7, if you can double the last digit, subtract it from the rest of the number should be divisible by 7 with no remainder. That one's a little trickier. I've never quite understood the divisibility rule for 7. I don't know. Double the last number and then subtract it, and it's a whole thing. Sometimes it's just easier to put it in a box and see if it works. 8s, the last 3 digits form a number that's divisible by 8. 9s, the sum of all the digits is divisible by 9. So you're adding up all of those digits and then dividing. And 10 is if it ends in a 0. Also, in your book, it says, nope, it just gives you those same ones. On page 231, it doesn't even cover 7. It's like 7s don't have a rule. Skipped 7. So let's write the prime factorization of 63. I do not think I put this on your sheet, but fill it on in. Prime factorization of 63. What numbers are you going to pick to work with for 63? 9 and 7. I do not think they did. They picked 3 and 21. But in the end, if we do 63 and 9 times 7, and this is 3 times 3, it still works out as the same thing, right? How would I write that in exponential form?
3 squared times 7.
3 squared times 7, because I have 2 3s. So, utilizing this way of factoring numbers is how they want you to simplify fractions. You do not have to do it this way. If you are more comfortable just dividing each one by a number and reducing them down, that's fine too. But this is what they suggest. So, simplest form. We want our fractions to be in simplest form. That means that the numerator and the denominator have no common factors, only one. Simplest form means that a numerator and a denominator have no other common factors. So, written in simplest form, we have 40 seconds that they want us to write in simplest form. And I think I have all of these on the back of your paper, but I didn't leave you a lot of room to write because there's so many of them. So we can look at this and say that 10 is divisible by what number that 42 is divisible by? 2. So one way to do that would be to say that this is 5 over 21 because those are both divisible by 2. The book suggests that you write down all of the factors or the prime factorization of each of these numbers. So the prime factorization of 10 is 5 times 2, and 41 is 21 times 2. And then they say that these both have a 2. We can cancel that out. When we have a 2 over a 2, it reduces down to a solid 1, which we know is just, 1 times anything is just that number. So when we cancel those out, we end up with 5 over 21. If we get to harder numbers, this might be something to look into. A way to do this. Laura, keep your eyes open. This might be a way to work these out, okay? Once we get into adding some letters to these fractions, you might want to write them out this way. 9/27ths. They are both divisible by 3. In fact, they both have 2 3s. They wrote out the prime factorization. If I can cancel out both 3's on top, what does that become? 1/3. Because I have canceled out these 3's and these 3's, I am only left with a 1 hanging out up there. So my answer would be 1/3. Another way would be to just divide both of those by 9. Next we have 8/36.
2 over 9.
2 over 9, you say, huh? We can cancel out a 4. This is not a prime factorization because there was still a 4 there. When we take out that 4, we end up with 2/9. (50/22). 25/11. We can say that this is the same as 5 times 5 times 2 and 11 times 2. We can cancel out our 2's and that leaves us with 25/11. If I were to reduce that down to a mixed number, what would that be? How many times will 11 go into 25?
Twice.
With how many left over?
3.
So 2 and 3/11ths. 9/90ths. What can I take out of both of those? A 9. What does that reduce down to then? 1/10. Do you guys kind of understand how this prime factorization and canceling out common factors works? 35/75ths.
15. Oh, 5.
We can take out a 5 out of both of them. That leaves us with 7 on the top and what on the bottom? 15. Now we get into some algebra. Yay, it's the best. When we have these letters also in our fractions. So we're going to break this down into the same way as we did when we were factoring out numbers, okay? 7 times a to the 3rd power just means a times a times a. 56 times a squared. So they break this down and they say 7 times a times a times a. And then they break 56 down into its factors of 7 and 8 and a times a. This is the same as what we were just doing. If there's anything there that we can cancel out, we can cancel if it's on the top and the bottom. So we have a 7 here. We can cancel out and we have an a and we have an a. We can just get rid of those because they're on both top and bottom. So when we reduce that down, we end up with just one a left on top and an 8 left on bottom. Another way to do this, if you don't want to write out all of your factors like that, is to look at our exponents. When we divide something with an exponent in it, we subtract our exponents. So if I have a to the 3rd up here and a to the 2nd down here, 3 minus 2 is 1. So that tells me I'm going to have 1a left on top. Okay? Oh, was that our only example? Yeah, that's our only example with a letter. So we might look at a couple of more of those in a second. Next, we're going to determine whether fractions are equivalent. Remember, equivalent means that they can reduce down to the same thing. So when we have 3/9 and we reduce it down, it becomes 1/3. When we have 2/6 and we reduce it down, it becomes 1/3. Mason, close your Chromebook. Close your Chromebook.
I thought we went across.
Yep, we're getting there.
Oh, okay. I thought we already learned that.
We did.
Okay.
We did. So we reduce those down and they equal that same number, so they are equivalent. An easier way to do this is to cross multiply. Okay, we can look at our cross products. If we have 24 times 2, so bottom times top of the other one, if that is the same as this bottom times the top of the other one, then we have equivalent fractions. So 24 times 2 is 48. 6 times 8 is 48. So therefore, those are equal. If you multiply those across and they do not equal each other, they are not equivalent fractions. So determine whether 2/5 and 4/11 are equivalent. Are 2/5 and 4/11 equivalent? No, because we end up with 20 and 22. They do not equal each other, so those are not equivalent fractions. So looking at, I'm just going to leave this up here, and we're going to work through something real quick. This is one of your problems. I have 200, whoop, I can't write there, sorry. 224 a cubed b to the 4th c squared over 16 a
Write this down.
b to the 4th c squared. And I want to reduce that and write it in the simplest form. So I need to look at this and work it out and figure out what my simplest form is. We can cross out the c's. They both are to the squared, so they will cross each other out. The b's are both to the 4th. They will cross each other out. Then what? We can divide. Let's see if 16 goes into 224 evenly. I bet you it does. 224, 16, it goes in there one time with 6 left over. Oh, what do you think? 4 times 24, 64, 14 times. So then what do I do to my A's? I can. What do I have left? Not just 2. 2 A's is different than a squared. So I have to make sure I say it as I had 14 a squared. Questions about today's assignment? Okay, your homework.